Hello class. Today we're going to be talking about a limit of trig functions here. Before we begin, I would like to ask you guys to these three questions as I do now. Now, first one is the triangle. As you can see here, triangle ABC. Oops. Triangle ABC with the angle x given in this way. Now, second one is a sector, so we're looking at this area. Same condition, A prime, B prime, C prime, where x is the measure of the central angle here. Now, third one is in fact right triangle, because B double prime and B double prime and C double prime, this becomes a tangent to the circle A double prime at C double prime. Now, I'm looking for the area all the way extends to this point, right? So that's the area that I'm looking for. All right, so I'm going to give you a couple, minutes for you guys to think about, and let's try to work on this one together. All right, now, then the first one, triangle. How are we going to find the area of this triangle? In fact, what we like to do is, since area of the triangle is 1/2 length of one side times length of the other side. So here, if you have to assume, for example, this, let's say this is equal to 1, this is equal to 1, and we are looking at unicircle. So how about that? In this case, then we will end up getting this length, which is AB, 1 times the other side AB, and sine of x. Therefore, this simply becomes sine of x over 2. That becomes our area of this triangle. Now, how about the second one? In this case, area now becomes a smaller portion, the ratio between the measure of the angle x out of 2 pi. 2 pi would have been the whole circle of simply pi r, which is 1 square. Now here you will realize that pi cancels out, hence leaving you with x over 2. Now the third one. Once again, the area is in this case 1/2 base times height. The base is simply here a double prime c double prime, which is equal to 1. But if this is the base, because this angle is a right angle, height will be b double prime and c double prime. Knowing that the x relationship between x and 1, we can realize that the length of b prime and b double prime and c double prime would have been equal to simply tangent of x. Now, but when you look into these three figures, you will realize that the one on the right, this has the biggest area, while the second one would have been this, because it has a little bit of this is a sector, so therefore this is a little bit greater than a triangle. Now, then one relationship which we can realize here is that sine of x over 2, which represented the area of the triangle, has to be a bit less than x over 2, which is the area of the triangle, and then a sector, and tangent x over 2 would have been the biggest. Now, since all of them has 2 common, what if you have to multiply by 2 on all 3 sides? Then we get to realize sine of x is less than x, which is less than tangent. Now, this is true that x is greater than 0 and less than pi over 2. Definitely, this case is true. Now what we'd like to do is, what if you have to divide all 3 sides by sine of x? Then you will realize something quite interesting. Then on the left side becomes 1, and then the middle side becomes x over sine of x. Third side becomes simply 1 over cosine of x. Now, since the values are in this way, if we have to take the limit of all 3, in other words, as of now, we realize that this x over sine of x is between 1 and 1 over cosine of x. Now, knowing that if you have to use the limit, then limit of 1 as x approaches 0. In fact, that would be smaller than limit of x over sine of x as x approaches 0, and then limit of 1 over cosine of x as x approaches 0. But as you realize that this portion, and these are the boundaries for this limit value. Now, but as x approaches 0, you will realize that the upper portion, upper boundary, will approach simply 1. The lower boundary is 1. Then, in order for this number to be between 1 and 1, I mean, technically, the only thing that's possible is when this limit becomes sine, as x approaches 0, has to be equal to 1 also. And this is called squeeze theorem, meaning upper boundary and lower boundary is squeezing the value inside to be one particular value, in this case 1. Now, then here, one thing that we get to realize is this. Since now we established the fact that limit of sine of x over x, actually what we have done earlier was x over sine of x as x approaches 0. Since we established that this was equal to 1, we will then realize the reciprocal of that, which is a limit of sine of x over x, will as x approaches 0, will still be equal to 1. Now, this is actually very important. Just to show you, if you had to use the graphing calculator here, so go to y equals sine of x divided by x. Now, if you have to zoom standard number 6 over here, then you will be able to see a nice picture. As you can see, as x approaches 0, let me just bring this one down. A bit smaller. As x approaches 0, we realize that y is approaching right over here, which is equal to 1. Now, then visually we are able to see it also. Then in this case, we need to, knowing this one, we need to study a few other form of limit with sine of x over x. Now, then in that case, let me just give you one question first. What if we have a limit of sine of x over 2x as x approaches 0? Now, you see, notice that unlike the previous question, even though, or in case of sine, we have coefficient of x is simply 1, while the bottom one has coefficient of 2. How are we going to solve this? Now, in fact, this can be solved based upon the previous one. We realized the limit of sine of x over x, but 2 is here, so I'm just going to bring it to the front as 1/2. Now, by the property of limit, we get to realize that here, this portion now matches with our previous conclusion that it is equal to 1. Now, that means this portion will be equal to 1. So we end up getting limit as x approaches 0, that's equal to 1/2 times 1. All right, then what is that equal to? Simply, our answer becomes 1/2. Okay, what if I have to give you the next question? You see, the whole idea is we need to match this angle and that particular denominator. What if I were to give you another question? Limit of sine of 3x over x. Notice that 3 is the coefficient of the numerator with sine function, trig function, and then the denominator is simply x. Notice that they're not matching. And I cannot simply take 3 out either out of the sine function. Therefore, we need to do something else. What can we do? Oh, that's right. We can multiply to match the numerator of 3x within the function of sine. We can multiply the denominator by 3. But when we do that, we got to do the same thing on the numerator so that we're not changing the value that we are about to evaluate. Now, then, in this case, this becomes limit x approaches 0 of 3 times sine of 3x over 3x. Notice here, guys, the angle 3x and then the denominator 3x, they are matching exactly. All right, then we know that this portion becomes 1 just like earlier. Therefore, this becomes simply 3. All right, now, how about the next question? Limit of sine of mx whole thing over nx as x approaches 0. Now, how are we going to approach the questions like these? Now, once again, this m cannot go in and out of the sine function quite easily, but n is relatively very flexible. So what we can do is this. What if you had to multiply just to match mx, bottom by m? That means we're going to multiply top by m also. So this now simplifies into limit of m times sine of mx over n times mx. Then, well, just like before, we realize that this portion is equal to 1, which, as x approaches 0, we will realize that this whole expression will simplify into m over n. Now, this is quite interesting because m happened to be the coefficient of x from the sine function, while the n was the coefficient of the denominator. And in fact, some people memorize this one as a technique for them to evaluate trig functions rather quickly. Then, let me give you a couple more questions. Given that the sine of mx over nx will it always be m over n? My next question that I would like to give you would have been something like this. Let us say limit of sine of 2x over 5x. But this time, instead of x is approaching 0, let us assume that x is approaching infinity. How about that? But when you look into this one thing that you will realize is that this sine function, sine of 2x, will be between two values, such as 1 and -1. It will fluctuate between those two. So intuitively, numerator will be within 1 and -1, while denominators keep on increasing as x approaches infinity. So what some people could say is that top is very small number, while the bottom one approaches infinity. Hence, it's got to be approaching infinity, 0, in fact. But one way which we can do it is through this way, because as we mentioned earlier, limit of sine of 2x, because sine of 2x goes from 1 through -1 over 5x as x approaches infinity, and yes, has to be less than or equal to, in fact, limit of 1 over 5x as x approaches infinity. How about that? Now, but this one has to be greater than or equal to limit of -1, because -1 is less than sine of 2x for the most part, and then 5x as x approaches infinity. Now, here, interesting fact here is that this portion will approach, yes, that's right, 0, because top is the constant, and as denominator increases continuously. How about the other side? Same thing. numerator was fixed at 1 and denominator is approaching infinity, so therefore this will approach 0 also. Now, when you look at it, the function in the middle, or the limit expression in the middle, has to be between 0 and 0. Only possible solution is if this portion is equal to 0. There it goes. That's a little proof why this one is equal to 0. Now, all right, then you will realize the sine of m, if I have to put this one into dual screen, sine of mx over nx, it doesn't always mean that this will be equal to m over n, or rather it can be other stuff. We have to look at it in the context of what the value of sine, what the value of x is approaching. All right, then just to continue further, let me get you one more classic example. It would have been this limit as x approaches infinity, notice, and then multiply x times sine of 1 over x. Now, how would you evaluate this limit? You might wonder, okay, how does this look similar to what we've been doing so far? Because the angle within the sine was 1 over x. In fact, if you were to rewrite this one, wouldn't it be something like this? As x approaches infinity, and then I'm going to write down sine of 1 over x. But here, in order for x to take the form of this one, we have to divide by 1 over x. And when you multiply top and bottom by x, you will realize the sine of the 1 over x still stays there, but x will be multiplying the sine function. Now, then in this case, what's going to be happening? Since sine of this over this, and as you can see, as x approaches infinity, 1 over infinity will be approaching 0, so as this one. So this is essentially let a is equal to 1 over x. If you have to write it in the other way, then limit of sine of a. Notice 1 over x is now equal to a over a. As x approaches infinity, what happens to a? A will in fact approach 0. You see, as x approaches infinity, a will approach 0. Then this is the exactly same format as the previous one. Therefore, our answer will be equal to 1. All right, now, so this one was the case for sine function. Now, then let me try to get you a couple more questions, and for you to enjoy those questions, here's the couple other ones. All right, so the first example that I'd like to give you would have been this. Limit of tangent, not sine, but tangent of x over x as x approaches 0. Now, once again, in this case, if you have to plug in 0 in place of tangent and also 0, then you will get 0 over 0, which is indeterminate form. Therefore, we need to do something about this. Aha, if you remember what tangent was, you will realize that this is the limit. Tangent, in fact, is sine of x over cosine of x, and then this x is dividing, and that's x approaches 0. Now, when you look into this one, you will probably realize that this portion, sine of x over x, is essentially equal to 1. Therefore, limit of cosine as x approaches 0, this value will be still equal to 1, which makes this one to be 1 also. Now, how about the next question? Limit of 1 minus cosine x over x as x approaches 0. Once again, I intentionally, this is actually a very, very popular expression, which will be helpful for us if you have to remember that limit of 1 minus cosine of x over x as x approaches 0 is a certain particular value. Now, in order for us to see this one, what we're going to do, we cannot factor. As you can see, there's nothing much to factor. So one thing that which we can do is we can multiply by the conjugate of 1 minus cosine of x, which will be 1 plus cosine of x. Now, we got to do the same thing on the bottom, 1 plus cosine of x. Now, then you will realize that this is equal to limit as x approaches 0, this becomes 1 minus cosine squared, which essentially is equal to sine square x over x times 1 plus cosine of x. Now, here, sine squared, if you have to rewrite this one, it might be a bit easier for you to see. This one would have been equal to limit times sine of x times sine of x, which makes sine square x all over x times 1 plus cosine of x as x approaches infinity. And what do you realize? Here, once again, sine x over x will be equal to 1. And as x approaches 0, then what do we end up getting? This becomes limit. As x approaches 0, we get to have 0 over 1 plus 1, which is simply equal to 0 in this case. Alright, there are other types of trig functions with limits, but I put them on the side as a practice questions. And as for now, have a great day, and I'll see you later.